In this video, we'll make sense of async and await in Swift. We'll see what they are and why they matter, the basic syntax, how they fit into your code, real examples that show them in action, and the most common mistakes developers make. Let's start briefly with point 1. Have you ever tapped a button in your Swift app and it just froze? That's what happens when your code runs synchronously. Each line waits for the one before it to finish. Async and await fix that. Async runs long tasks in the background. Await pauses just one line until the result's ready, then your code continues smoothly. Swift uses async and await mainly for two reasons. First, when your app needs to wait for something external, like fetching data from an API or downloading an image. Second, when a task takes time to finish, like saving a file, processing data, or running calculations. In both cases, async and await keep your app's UI smooth and responsive. And to understand how that works, let's look at the syntax. In this simpler version, we mark the function load data with async. Then, inside the button, we wrap the call in a task, which tells Swift to run that work in the background and call the function with await. Some async functions can also fail. Here, tapping fetch data runs an async task that may succeed or fail, showing either a success message or an error. In that case, we mark that function as async throws, meaning it can both pause and throw errors. To handle possible errors, we first wrap the call in a do-catch block. Inside do, we'd use try await to call the async function that might fail. Async functions can also return values. In this example, the function randomly returns a username string or nil if nothing is found. We place async before the return arrow to show it returns later. When calling it, we use if let await to unwrap the result once ready. Now let's compare some examples. Let's say you're building a simple profile page. It loads a username, a profile picture, and a small gallery. You tap the load button and everything stops. The app freezes. You can't scroll, the button doesn't animate, even the spinner is stuck. It looks broken. What happened? You forgot about async and await. You loaded each image from a URL and you didn't notice Swift's warning or ignored it. So when you press the button, it blocks the main thread the whole time. Now, let's see the same profile screen using async and await. This time, the fetching functions are all marked async or async throws, so we can use URL session, which is a class built specifically for asynchronous work. The lines that simulate API calls all have await. Inside the load profile function, we use to async let to load both avatar and gallery images at once and update the state once it's done. When you tap load profile data, the follow button still works, and you can scroll smoothly while it loads. Now let's tackle heavy local work, like compressing images. The UI looks simple, just a button and a progress bar. But inside compress images sync, everything runs on the main thread. It downloads, decodes, and compresses 20 images one by one. The progress value updates, but the UI can't redraw until it's done. So the bar appears frozen, then jumps straight to 100%. In the async version, the logic stays similar, but the slow steps are awaited. The resize function uses UI graphics image renderer, which only works synchronously. To avoid blocking the main thread, we run it inside dispatch queue. Old-style concurrency acting as a bridge. Since that uses callbacks instead of pausing, we wrap it in with checked continuation, so the async function can pause and stay within Swift's new concurrency system. When async code runs in the background, changing state there is unsafe. SwiftUI handles all UI work on the main thread. Await main actor.run lets you temporarily hop back to the main thread just for that code block. With these changes, tapping the button updates the progress bar, so the UI no longer feels frozen. Now let's look at a few common mistakes developers make when using them. First mistake, forgetting to mark a function as async. You can't just drop an await inside any function. Swift needs to know that function can pause. Second mistake, calling an async function that can throw, but forgetting try. If a function is marked async throws, you need both keywords. Swift will remind you, but it's easy to miss when converting older code to async. Third mistake, mixing dispatch queue with async code. That was useful before async and await existed, but now task already handles background work for you. Fourth mistake, blocking inside async code. Just because a function is async doesn't mean sleep or long loops suddenly become safe. A better way is to use await task sleep and add try to quietly handle cancellations. This pauses only the current task, not the whole UI. And that wraps up all the basics for async and await in Swift. If you've enjoyed it, don't forget to like and subscribe. And if you want to debug smarter with remote logs, crash reports, and real-time error tracking, you can sign up for free at bugfender.com. I'm Alish, founder of Bugfender, trusted by over 34,000 brands to fix bugs faster and build better apps. Thanks for watching, and see you in the next one.